Assalamualaikum and hello guys, this is for question 1, chapter 7, Haloalkanes. For question 1a, we have to cover 3 questions based on structure X. Let's go one by one. First question, you have to give the name for X. As we already know, we have to determine the longest carbon chain for our parent. So it's going to be number 1 here, 2 and then 3, so we have 2 substituents here, and we have to give the name according to IUPAC nomenclature, where it's going to be 2-chloro for Cl here and 2-methyl for CH3 here, and the propane is our parent, 3 carbon chains. Next, we have to write the reaction mechanism when X reacts with H2O. First thing first, you have to identify what is the class of haloalkane here. So as you see here, this is tertiary haloalkane because of this carbon atom is tertiary carbon. So tertiary carbon is more readily to lose the halogen atom to form more stable tertiary carbocation. So this is the moment nucleophile, our water, can attack the carbocation. So how to write the reaction mechanism? First thing first, you have to draw the structure X. We are going to start from here, and between this alpha carbon, our carbon here, it attached to Cl atom, which is more electronegative. So our electron will be given from this bond towards Cl. So you will form the product where you detach the Cl minus, and this carbon atom is going to be our carbocation. Next part, you have our reagent, which is water itself. So the lone pair from the water will attack the carbocation. Next, you will form the bond between carbon atom and oxygen atom for the water molecules. However, this oxygen lose one lone pair to create this bond, so plus should be on the oxygen atom. Next, what we're gonna do, we have another water molecule. This lone pair from water molecule here will attack this hydrogen. Should be any hydrogen here. I choose this one. And this bond will be given to oxygen because oxygen is more electronegative. Then you will get the final product, which is alcohol. Settle for reaction mechanism where you form carbocation as the intermediate for tertiary haloalkane. Next one, we have to give the type of reaction for this alkyl halide X. As I mentioned before, this is our tertiary haloalkane. So it is more favored to undergo SN1 because it can produce more stable carbocation. So the final answer should be unimolecular nucleophilic substitution, or what we've known as SN1. Make sure N here is lower subscript. Next, question 1b. You have to write the reaction equations when 1-chloropropane reacts with these 3 reagents. So we have 3 of them. Each equation you will get 1 mark. So the first question, 1 Roman, you have to write the reaction, draw the structure for this haloalkane first. And then we have aqueous and AOH. You have to put in phase AQ, aqueous. And every single reaction for haloalkane, you must undergo the reaction under reflux. So reflux should be below the arrow. And here you will do just a simple substitution. This halogen atom will substitute with hydroxyl group. So you will form alcohol and NaCl as our side product. Next, we have the same haloalkane reacts with excess ammonia. So, I'm going to write the equation where we need ethanol as our solvent and undergoes under reflux. You will substitute NH2 minus from ammonia molecules at this halogen position. And then we have another one more, which is H+. It will attract Cl minus from this here. So you got HCl as our side product. Next, 3 Roman. You have the reaction for the same haloalkane with KCN in solvent respectively. So I'm going to write the drawing for 1-chloropropane with KCN, you need ethanol as a solvent on the top of the arrow, and below it you have reflux. So this is the moment you are going to substitute CN here, CN minus, with Cl here. So you are going to put the position, and K plus from KCN will attract Cl minus here. So you form KCl as our side product. The last question 1C, this is the reaction scheme where you convert between reagent P and reagent Q here. So you have to identify what are those. So as I see here, I can see that you have magnesium in the middle between alkyl group and halogen. So of course we are going to use magnesium as our reagent P, and this magnesium undergoes Grignard reagent. This is the hint. So I'm going to put reagent P magnesium in dry ether, always like that. And the last one, we need to identify Q. So the structure for reagent Q is based on what is the product that formed here. So you can see that this alkyl group is coming from this part. Hence, what I'm going to show here, based on hydrolysis, we add hydrogen here and here. So I'm going to reverse back the reaction. So I'm going to remove this alkyl group, this one, and also hydrogen here. And we are going to put double bond between carbon and oxygen, and the rest of them stays the same. So you will have the structure for reagent Q like this one, which is our propanol. That's it for our question 1. I wish you all the best. Bye!